talking about sequences. So a sequence could be like 1, 5, 9, 13. Well, let's stop it. We'll say that that sequence stops. And we could call it a sub n. Well, sometimes we're not interested in the individual numbers of a sequence. Sometimes we care how many numbers are there total. Like when we did the movie theater problem, the last question said how many seats fit in the theater. So you wanted to take all of the sequence from a sub 1 up to some a sub n value and add them all together. So once we do that, we call it a series. So a series is denoted S sub n, and S standing for the sum of a sequence, which would be, in this case, 1 plus 5 plus 9 plus 13, which is 6, and 9 would be 15 and 28. So we need some way to represent a series as an equation. But the trouble is, the series changes every time the sequence gets longer or shorter. So what we do is we use a capital sigma, and then, so that is sigma, which represents find the sum. That's why they chose sigma, because it's sum. Find the sum of, and then we need the explicit formula, not the recursive. What is the explicit formula for this? Well, it's arithmetic. What's my common difference? 4. So I'm going to write 1 plus 4 n minus 1. So this is a sub 1 plus 4 times n minus 1. So that tells me what I'm going to be adding up. And then underneath the sigma, it tells you which term to start with. N equals, starting with 1, and I'm going to continue on until 4. Good. I was going to comment, but yeah. Now, we can use lots of different versions of this, and I'm actually going to make you do it a little differently. Okay? Did it tell me which terms I started with? Which term is this? Does it have to be 1? No. So this could be a sub 0, a sub 1, a sub 2, a sub 3. So you guys are going to have to learn how to switch between 1 and 0 or any other number that you wanted. So if I were to change that, the summation from n equals 0 up until, how far does it go? 3. Well, how would that change the equation? So it's 1 plus 4n. And that's going to give me the same thing. So what's a good way to transition between these two? So this, how did that change? From here to here, my n value went down 1. From here to here, what happened? Went down 1. From here to here, what happened? It went up 1. Why would that be? So my n's got smaller, which is going to do what to my n minus 1? Does that make sense? We'll get more into that in a minute, but Yeah, we'll get there. I don't want to go. That's where we're headed, but I don't want to do that yet. Okay. So if you look at the first page here. Oh, now, ooh, I'm not winning that battle. Okay. So this says rewrite each series as a sum. So it wants to know if I were to write this equation out with all of the addition signs, what would it look like? Well, how am I going to figure that out? Starts at 1, so I'm going to plug in 1. 4 times 1 squared is 4, plus 4 is 8. So a sub 1 is 8, and I'm going to add that to a sub 2. So I'm going to plug in 2. 2 squared is 4 times 4 is 16 plus 4 is 20. Plus 3 squared is 9 times 4 is 36, and 36 plus 4 is 40. Now I plug in 4. 16 times 4 is 64 plus 4 is 68, and 5 squared is 25, and 25 times 4 is 100, plus 4 is 104. So it's not asking you to add them up. It's just saying rewrite it as a sum. Now eventually you guys are going to get sick of this. For arithmetic and geometric, there are formulas. But this is a quadratic, and I don't know of any quadratic sum formulas. There's got to be one out there, but it's probably really complicated. All right, now for some reason, number 3 really confuses people. I don't know why. Yeah, it's 1 plus 2 plus 3 plus 4 plus 5. Okay? So for number 5, you're going to plug in 1 and 2 and 3 and 4 and 5 and 6 and then write it as an addition. When you get down to number 13, now it says evaluate the series. So you can see on the answer sheet, so on the answer sheet on waiting for we are in the total vortex. What's it called? Oh, I know what happened. Okay, so you can see here, all of your answers are going to be written as sums. And then down here, you're actually calculating the answers. Yeah. So on number 13, what happens when you plug in 1? 39. Plus, what happens when you plug in 2? So 40 minus 4 is 36. 40 minus 9 is 31. 40 minus 16 is 24. 40 minus 25 is 15. How many is that? 1, 2, 3, 4, 5. 40 minus 36 is 4. We got to go all the way to 7. So negative 9. 40 minus 49 is negative 9. So now, in your calculator, you add all those up, and I get 140. Okay? Not too bad. Okay, turn the page. So, for these problems, you need the explicit formula. And you have to be careful, because you have to distinguish between an explicit formula that starts at a sub 0 and an explicit formula that starts at a sub 1, because they're different. Basically, you're going to have an n minus 1 somewhere, depending on how you do it. So what type of pattern is this? Plus 1. So I could write this, if I chose this to be a sub 1 and this to be a sub 4. What is my formula in this case? 1, that's my first term, plus the common difference is 1 times n minus 1. Why n minus 1? Because I started at a sub 1. Okay? What would my a sub n formula be if I started at a sub 0? N. Well, those are different, so how can I get the same thing with two different formulas? Right, it's going to change my bounds on my sigma notation. So if I did a sub 1, it would be from n equals 1 to 4, 1 plus 1 times n minus 1. If I did it the other way, so this would be 1 plus n, what's the difference? It goes to 3 instead of 4. Could I start at 7? So let's say I wanted to start at n equals, that's an n, equals 6. So that's going to be sigma notation from n equals 6 until 6, 7, 8, 9. Right? And it's going to be 1 plus 1 times. Well, I need to get this number down to what in order for this equation to equal that? So 1 plus, what does this need to equal? For the first term, what does it need to equal? It needs to equal a total of 1, so this portion over here needs to equal 0, and I'm starting with 6, so that would be n minus 6. So if my n's increase 5, sorry, if my starting number increases 5, then the n's in my equation decrease by 5. Does that make sense? Because there's a bonus question that asks you to rewrite it. Yes? No. That's which term, the last term you calculate. So that's a really good point. This number does not tell me how many terms there are. It's the n value of the last term. And actually, next week sometime, we're going to go all the way to infinity. Well, it's really easy. Either the answer is infinity. I mean, if you add up an infinite number of numbers, you're going to get infinity. Or, if the numbers are shrinking fast enough, you can actually approach a specific number. Like if I had 1/2 plus 1/4 plus 1/8 plus 1/16. These numbers are getting smaller and smaller, and eventually I'm adding numbers that are so close to 0 we can't distinguish them. This approaches some number close to 1. So 1, that would be 3/4, that would be 7/8, that would be 15/16. It's getting closer and closer to 1. So this, if I added this sum from 1 to infinity, I think the answer for that one is 1. And there's a simple way to determine if that's going to happen or not. We'll get there. We'll cross that bridge when we come to it. Okay, so for these, you need the explicit formula. Okay? But they're not necessarily arithmetic or geometric. What is that formula? What's the pattern? So if I put a 1 down there, my pattern is leave the numerator the same, and I'm going to add 1 in the denominators. Well, that doesn't really help. That's the recursive formula. I need the explicit formula. So remember, recursive relies on previous terms, Explicit relies on n. So if I wanted to know what is a sub 16 going to equal? 1 over 16. So my a sub n is simply 1 over n. Does that make sense? Ooh, good job. I thought you were going to mess up, but you got it. So this one is going to be the summation of 1 over n, starting at n equals 1 up to 6. Now, just for your information, don't write this down. The summation, what if I started at n sub n equals 3? Well, this, when I plug in 3 for the first term, what does this value need to be? 1. Up to, let's see, 3, 4, 5, 6, 7, 8. So those are exactly the same. Because when I plug in 1 here for my first term, I get this. If I plug in 3 here, my first term is still 1. Okay? And then you have 2 critical thinking questions. Let's talk about the first one a little bit. How do I know if those 2 things are the same? I could write them all out. Term 1, term 2, term 3, term 4, all the way to 50. 21, 22, 23, all the way to 70. That would be a waste of my time. Plug what in? How would you tell if they're the same? I don't. Can you graph these? No, you can't because it's gonna. I, I guess you could. So Braden's saying they both have 49. It's actually 50 numbers, right? The distance between n, between the x equals 1 and x equals 50 is 49 places. How many numbers are there from 1 to 50? 50. So the distance is 49, or you can say there are 50 numbers. Are there 50 numbers from 21 to 70? Yes, so they could be the same. So how are we going to check? Why are they? Oh, well, that's a really cool way to do it. So, so if I plug in, how did you say that? If you plug, so 1 over 1 on this side, and this is 1 over 21 plus 20, minus 20. Those are both 1 over 1. Now, if you hadn't have figured out that there were 50 numbers, you would probably need to plug in 1 and then plug in 2 and see that that matches 21 and 22. Then you also need to plug in 50 and 70 to make sure those matched. Yes. Yes. But if you know that they have the same amount of numbers, then you don't need to plug those last ones in. So, in that case, yes, those are the same thing. Okay? Get to work. And good luck.